about some important features on a velocity versus time graph. And what exactly is a velocity versus time graph? If you remember from the first part of the chapter, we learned that a position versus time graph gives us a visual representation of velocity. A velocity versus time graph, or shows a graph that shows the change in velocity over time, actually is a graph of acceleration. Oop, hang on, let me get back over here. And that's what we're talking about. We're talking about an acceleration graph. That's what this graph represents. Now, there are some key intervals we have to look at when we are trying to discern both the value positive and negative of velocity and the value positive negative of acceleration. Now, how can we tell whether something has so in this scenario, looking at this graph, how do we know whether the velocity is positive or negative? Okay, I have drawn a dotted line. You can tell by looking at it. I have drawn a dotted line on here, right? I'm going to go ahead and highlight it now. I'm going to use a yellow. So here, okay, so everything above this line represents a positive velocity for this object. Everything below this line, because this is the 0 point, represents a negative velocity. I'm going to go ahead and undo those last couple of things and draw them with a pencil so we can see it. So above, we've got a positive velocity. Below, you've got a negative velocity. Okay, so what would that look like? I'm going to take a highlighter, and I'm just going to show you. So from here to here, I'm looking at these intervals. I've marked some intervals. We're going to talk about them more. But from there to there is a positive velocity. I'm going to draw my intervals up here too. So here's my intervals. I've got one there. Sorry about that. One. Go away. There. Oops. Here. Here. And then here. Okay, so these are the velocities. We're just going to evaluate the velocity in all these. All right, let's come back over here. So the second one. Is it above that yellow line? Well, of course it is. So this is also a positive velocity. Okay, so this from here to here represents a positive velocity. So we're going to come over here, and we're going to say this is also a positive velocity. Positive velocity. What about the next section? Is it above that yellow line? Why, yes, it is. So this is also a positive velocity here. Right? I know this seems tedious. There's a reason for it. Just hang with me. So this is also a positive velocity. And then finally, the next little segment from here down to the yellow line, because we're evaluating at all these spots. Oops, I'm going to redo that one. See if I can get a little closer. All right, down to there. It's still above the yellow line. It's a positive velocity. I'll write that down. Now, we have one more section. It's from this yellow line down. What is that one? At this point, we have a negative velocity. How do we know that? Because the velocity is shown over here on the left-hand side, and we can see that we're below 0. So if we have a velocity that's below 0, we would term that a negative velocity. So in this last section over here, we have a negative velocity. Okay. Now, let's evaluate the acceleration. Is the acceleration in each one of these situations positive or negative? All right, I'm going to pull out a different color for this one. I'm going to use orange for this one. Okay, how do we discern whether acceleration is positive or negative? Well, we look at the slope. So in each one of these scenarios, when we evaluate each one of these sections, we got to say, is this a positive slope or a negative slope? So let's start by looking at this first section. Let's see if I can add to this. All right, so here, clearly, in this section here, we clearly have a positive slope. So that would mean that in this section here, we have a positive acceleration. Okay, let's look at the next section. This has a negative slope. If you just took rise over run, this would be a negative number, meaning this has a negative acceleration. So in this section here, we're going to say it has a negative acceleration. In the next section, obviously it's positive again. So we're going to mark that, all right. We can see there that we have a positive acceleration. And again, we're going to evaluate to this yellow line. So in the next part, we've got a negative slope. Okay, so here to here, we have a negative slope. That means we have a negative acceleration. And in the next section, we still have a negative slope. So we still have a negative acceleration, a negative value for acceleration. All right. Negative value for acceleration. Okay, we're almost done here. Now, the next thing I'm going to say is, what does that mean? How do we tell what's happening in a position of velocity versus time graph? Well, we know that if velocity and acceleration have the same signs, then that means that something is speeding up. Okay, so from here to here, the object is speeding up. All right, let's look at the next section. We have a positive velocity still, but our acceleration is negative. That means in this second section here, the object is slowing down. So from here to here, because we have, why? Because we have a positive velocity, but we have a negative acceleration. What that means is the object is slowing down. All right, what about in our next section? Again, we've got a positive velocity, we've got a positive acceleration. From here to here, that means that the object is speeding up. And the next section would tell me, again, I'm just evaluating to the yellow line. I've got a positive velocity, I've got a negative acceleration. What does that mean? That means that the acceleration is working in the opposite direction of the velocity. And if the acceleration is working in the opposite direction of the velocity, what would that acceleration be doing? It would be slowing it down. Okay? That's what happened here, slowing down. And then finally, our next section, I've now got a negative velocity and a negative acceleration. So when I have the same signs in my velocity and my acceleration, that means the object is speeding up. So what does that mean in this particular segment of this graph? Well, in this particular segment of a graph, it means it's speeding up, but in the opposite direction. That's what that means. Okay? So I'm gonna go, so that's kind of, so if you're trying to evaluate if something is speeding up or slowing down, you've got to look at the signs. If the velocity and the acceleration both have the same sign, that means the object is speeding up. If one of them has, if you have different signs, that means the object is slowing down. So I do want to scroll down here because I want you to see just real quick, for this particular graph, we have an object moving in two different directions. Okay, so from here all the way up to here, all the way the object is moving in one direction. When the object gets to here, now the object is moving in a different direction. So this dividing line, right? Because we're only moving in one direction, right? This is basically acceleration in one dimension, not direction, but one dimension, right? We're using negative as being one direction and positive would be a different direction. So when we get to this point where our velocity becomes negative, what's actually happening is the object is now moving in a different direction. So that's kind of what that means. But hopefully that helps you to see when you're looking at a velocity versus time graph, you've got to evaluate where slopes change and where an object might move from a positive velocity to a negative velocity. So that's how you can evaluate that. I hope that is helpful.